In this related rate situation, we're going to look at a rocket that is rising vertically. Represents our rocket. We have an observer on the ground standing 20 miles from the rocket's launch point. So here's our observer. Let's call the distance between the observer and where the rocket was launched x. We know x is 20. We know that side is not going to change, that distance. The rocket rising vertically at the moment is at 40 miles, and that side of this triangle is changing. 5,400 miles per hour. How fast in radians per second is the angle of elevation between the ground and the observer's line of sight? So, of the rocket increasing when the rocket is at an elevation of 40 miles. Okay, so we want to know the rate at which this angle is changing from the observer. So let's model this situation. We have a right triangle, so we can use right triangle trig. And we'll use the tangent function. Anytime in related rates, if a side is constant, then we may plug in its value at the moment. So since the distance between the observer and where the rocket was launched from, that doesn't change, it's always 20, we'll substitute in 20 for x. Okay, next, we have it modeled. Let's take its derivative. So we have secant squared theta, d theta over dt, equals 1 over 20 dy over dt. Okay, next thing we're asked to find, we need to find out what the secant squared of theta is. Well, here's theta. We know theta is going to represent hypotenuse divided by the adjacent side from angle theta. At the moment, we're not given that length of the hypotenuse, but using Pythagorean theorem, we have 20 squared plus 40 squared equal 2,000. So the square root of 2,000 would represent this third side. The hypotenuse, we'll call it z. So secant squared is going to be the hypotenuse divided by the adjacent. So square root of 2,000 divided by 20. And it was squared. d theta over dt, 1 over 20. And dy over dt, that was the rate of change of the rocket. So that is 5,400. Okay, so from here, we're going to square what we see in red, multiply by its reciprocal to the other side, and d theta over dt represents rate of change of the angle in 54 radians per hour. Now, in the beginning of the problem, they asked us to write our final answer in radians per second. So we'll need to take this angle, divide it by 3,600 to get into radians per second. And here we have our answer.